Ну так.
А покажіть. Я якраз тобі казав, що ви мене ігноруєте.
В чому?
Я вам написав
Де?
в Фейсбуці. Ви нічого якраз не сказали у відповідь. Ну, я все традиційно казав, що працює. Ні, то добре, це працювало і так. Там з тим яка проблема. Так, працює. У вас, очевидно, якимось чином знижені правила безпеки.
Ага.
Проблема в тому, що програм-файл, під віндою програми йдуть програм-файл. Це приблизно та ж роль, що USR Bin в Linux. І туди звісти починають з Windows звісти, то заборонено писати. А ця програма пише тимчасовий файл прямо туди. Відповідно. А ні, стоп.
Що вона написала?
Ні, у вас ще правильно не туди, у вас тут стоїть.
Що?
Ну, воно не в програм файл, але у вас.
Так, але я до Java цю штуку не писала.
Ага, ні, то воно залежить від інсталяції Java. Тобто, якщо
я
Java
в цей
заінсталювалася.
говорю, бо то я міняла.
А, ні, я подумав, що у вас 100 не працює.
Так, я
що-
так.
А Java, якщо вона інтегрована в систему, якщо вона одна в системі, то ви її знаходите. Просто в мене за 5 копій там
Ну, ясно.
версій.
Ясно. Мені сповіщення не приходить, що з телеграму приходять, і зі слайду ніколи не
Фейсбук.
з Фейсбуку теж не приходить.
Вище?
О, а може ще не прийшло.
Він виїхав автостопний танк. Потім скажу.
Я вас тут зараз викличав щось співбесіду говорю. Мій брат прийде, він мене вважає.
Постараюся.
Ну, хоч так буде.
Чесно кажучи, хто ваш брат, я думаю, що це буде дуже складно.
Я знаю, то. So,
Okay.
you're here, but I knew about it.
Yeah, I'll be okay. I'm safe with the students.
Are you sure?
I'm not real sure. I have to be on my guard.
Сам прийде і вже працює.
Is anybody else with us?
No, Roman, yesterday autostop.
He's hiking the cars to get to another one city.
Oh, he's-
Another part of Ukraine.
Oh, okay, he's traveling.
Yeah. Young traveler.
But at the end of this, you will be able to explain it to him.
Yeah,
I
I
hope so.
will explain everything.
We'll go step by step. So we'll be repeating a little bit of last time, you know, kind of, and in addition, a little bit new stuff.
О, нет, я просто закрыл все видео,
So when it gets time, like I should stop, let me know. I could just start or somebody else.
No.
No,
Okay, this is it. Okay. So this is a program that calls okay, so there's a routine up on top called P1. Okay, so this is P1. And then there's an increment 1,000, like a second routine, an increment 200, an increment 30, and an increment 4. So they kind of call one another just to see this sequence of call. And so we'll start from the beginning. So we're going to do this, and I think with the other program, I wanted to show you re-entrant code.
Maybe we will pass our homework, like these questions which you gave us.
Well, yeah, either homework or we can answer them now. Just
Could you go through it because
Yeah.
we are not sure that we made it.
do we have the
Yeah, we can do it.
once you have the questions, and you can ask me the questions, and I'll see what you guys get. Okay.
Okay.
So one of you guys can have the code, and the other with the questions, or whatever you want.
We have the coding questions, and can you go through all the questions?
Yes, I will,
Answer
yeah.
them?
So the first question is,
What is the purpose of statement 3?
Okay,
It's like to store multiple registers, to use it at the end of the program to reset the registers after the execution.
okay, correct. We're going to store all the registers
In the
Yes.
register.
as who left it.
Mhm.
Who?
Like
Well, who left
our
who-
program.
No,
Like
the other guy that called us.
Yeah.
The operating, so basically at this point, let's say we started this program,
Okay.
you know, we went online and we just started something. So basically the operating system called this.
And after we need to reset it.
So we're saving the operating system's
Before the execution.
registers.
Yeah.
English.
Yeah.
He's just doing everything really fast, and
Yes.
it's not enough time for me to see.
Okay, we'll go slowly. Okay. So
Yes.
here's actually what happened. So you can make sure you can explain it to Roman.
I will.
Okay. This is you.
Okay.
You're using a system called TSO. You've got an editor, the TSO has an editor, so that's like, that would be similar to a command prompt on Windows or a shell on a Unix. Okay, so TSO starts up. Remember we talked about an address space? And to create an address space, you have to have all these tables, and computers got to do a lot of work to create an address space. So what the operating system has is it has TSO, and then it has a bunch of initiators. And these initiators are actually pre-built. So these address spaces are just kind of hanging around, they're not getting used, but they're already built. So anytime you want to do a little tiny program like this, it just gives you one of the address spaces, lets you run the program, you get done, and TSO still owns the initiator. So the next person gets on, Roman gets on, the initiators, one of these initiators are already there. So, and you'll see this a lot in sort of like computer science with users. A lot of times you pre-build things so the user doesn't have to wait. So this way this program will start very quickly because it just gets thrown into here and starts. So this initiator is a program, and it's got a save area. And then somewhere along the line, it calls, I forgot what I call it. Okay, so this is the demonstrate nested routines. This program, so it calls the program. And the first thing the program does is save registers. Whose registers?
This program saves registers.
This guy, the callers. So this guy saves this guy's registers.
Okay, and we are saving from 14s to the 12? Like
Right, correct.
14, 15?
For all
Yeah.
14.
So
Is it installation? Okay.
this guy, this is the initiator. The contents of register 13 right now, the contents of register 13 points to the initiator saver. So when we do a store multiple, we're going to do a store multiple of what? 14 through 12.
Like 14, 15, and then 0, 1, 2, 3.
Exactly.
Okay, and
But
there is,
12.
there is the elder mode and the register where we store. Like the first operand is for the register where we store this another data.
Right, and where are we going to store it?
In
We're going to store it in
13, 14.
pointed by 13,
Yeah.
offset 12 bytes.
Yes, that's what about the. We are storing in the register 14.
No, we're not storing in any register. We're storing the registers are being stored. Stored means put it in memory, not in registers. So we're taking the contents of the registers and putting them in
Okay. We are
virtual address space.
We are using R14 for the as the base register. No.
No, it's not a base.
No, base is 12. Okay.
No,
No, we are
it's just a register. It's a register that contains an address. Base register we'll talk about later. Base means a very certain purpose.
And this register 13 is just like default.
Yeah, when this guy called this, how did he call this guy? He did a BR 15. 15 contains this address. See, all this is in an address space. So this is an address space, and like everything else, hex. So this is an address space, and it has a number.
Okay.
Whose address space? This initiator. So you're here, you say start the program, the operating system says pick this initiator, you got its address space now. Your program then was loaded into this address space, so it's in the address space. Some initiator code and your program. So the first thing, according to this standard, is this guy. So first, how do I get to this program? Register 15 contains the entry point of the called program. So we've been always putting the entry point at top. It could be here or here or here. You follow me?
Yeah.
We're just, yes?
Yeah.
We're just putting it at the top to make it easy for me to explain to you.
Okay.
Okay.
Good? So, what's in register 15 right now?
Address of beginning of the program.
Yeah. Okay.
Yeah.
Now, when we return, when we're done with this program, where do we want to go back to?
Like just register.
No, whatever instruction is here.
Okay.
Do you follow?
Yeah.
Okay, so,
What was before execution?
yeah, so here's R13 is pointing to this. R15, right now, is pointing to this. And we want to go back to
That's why I thought that we started.
yeah, so R15 points to the contents of R15, points to this. The contents of R14 points to the next instruction. R13 is pointing to some save area. Why? Because everybody does it that way. You could use other registers, but then everybody's going to be confused. So the first thing, then what about these other registers? Well, like 0 and 12. Well, however this guy has them, when we go back, he's got to have them the same way. Otherwise, the program's going to go nuts. It's like taking out your memory. Okay, so the first thing we're going to do is start saving the contents of all the registers in this guy's save area. So, and we're going to save it in a very specific format. So a standard save area is 18 full words. So I'll just use the same words so I don't confuse those. So this program has something okay, we'll do that. But right now, register 13 is pointing where? Here or here?
Is there?
Left.
Yeah.
Oh, pretty good. So, what is this? So this is the first statement that's going to get executed. Okay. So just to make sure, start is just telling the compiler, hey, we're calling this program P1, and this is starting the code. This is assembly code. Notice start is an instruction to the assembler, so it doesn't take any space in memory. So where is it going to do this? 13 is pointing here. We don't know what this initiator calls this program. We don't care. It just 13 points to it. And it says where? 12 bytes off of R13. Well, 12 bytes is 0, 4, 8, C.
It's like
Because you're not human, you're a computer.
Yeah.
Okay. So 0, 4, 8, and C.
it's
So
like a place of return.
what?
It's like a place where the return is. Or,
Yeah, we'll see exactly. Okay.
okay.
So this will be R14. So it's going to store where? Pointed to by 13, offset by C. What's going to be here? 14. The next one is the next one is
0.
Well,
Yep.
so we got one instruction code.
Yeah.
Okay. So we're like 1/100th of a microsecond into this computer
Safe
execution.
area of this initiator
of the program.
or of the program.
Who, when Mrs. IBM coded this initiator program, she somewhere put in an area for a save area.
Okay.
And Mrs. IBM made sure that when this program calls another program, R13 will point to this initiator save area. So this is like right here.
Okay.
You believe entirely or just?
We believe.
Okay. So now we save the contents of all these registers. So what's the next instruction? Okay. So Ballard. Now, there's several ways to handle this, and I'll show you a couple other ways. We'll see how it goes. I don't want to confuse you guys, but like this is one way to do this.
I have one question. Is
Yeah.
there just instruction to say the base register is
Don't worry about base. I'll talk about base register
okay?
later.
Because if you point to like 0 there, then you use this instruction not to branch, but to set the base register.
Don't worry about the base.
Okay.
Base register has a certain meaning, and I'll tell you when something is a base register.
Okay.
Okay? Base register means something to the assembler, not to the machine. Okay? So in other words, what we're going to be doing is we're going to be calculating offsets into the program. Periodically, I'm going to say so many bytes into the program. And if you say how many bytes, you got to say from where. So it could be the first byte of the program, or it could be over here, or it could be over here. So I'm going to get a register to point to someplace here. So when I talk about displacement, distance, I have a base to talk from. I have a base to reference. If you do mountain climbing, what do you have? You have a base, and then you climb. And you say, I climbed 2,000 feet today. And you're going to go, well, where did you start? That's the base.
Like the address counter. Address counter is the base register, like.
It's just going to contain an address in virtual storage. And it'll be used to count a displacement.
Okay.
So Ballard is an interesting instruction. What it does is, there's a couple things I want to talk about here. First is, how does Ballard work? Then second thing I want to get across is, register 0 is used differently when it contains an address. Okay? So here, register 13 contains an address in virtual storage. Register 13 contains an address in virtual storage.
But we don't know our.
Okay, so if it wants to know what's in 13, you go inside and you go, oh, that's an address in virtual memory. But register 0, when you say there's an address in it, the machine goes, I don't care. I'm assuming it contains a 0. So it's a way to like get a register with 0 in it without. Okay, so here's what's going to happen. There's 2 registers involved in this Ballard. Register 12 and the instruction address register. So the instruction address register is the right now this guy, because we're executing this program now. So, and the instruction address register is pointing to, we're executing this I'm sorry. Ballard 12-0. When we're executing this, the instruction address register is pointing here. You guys real good on that?
Yeah.
Yes.
Okay. So what Ballard does, it involves 2 registers. The instruction address register and R12. Okay. And what this does is it says
Am I right? Like it's.
it sort of swaps addresses. So it says take whatever's in here. Wait. Yeah. I got it backwards. It says take the contents of the instruction address register and put it into this register. I'm going to modify this so I don't confuse it. Let's say, just to explain the instruction. This is how this instruction normally works. It's a way to swap. The contents of the instruction address register goes here. And then the contents of this goes into the and then the machine, it's done. So the next instruction is whatever this pointed to. Good?
Yeah.
Okay. We're doing something different because instead of using a regular register, we're using this weird register. Yeah. But when it's our 0, we say just don't do anything. So what did we effectively do? We got the contents of the instruction address register in R12. That's what this does.
Yeah.
Good.
Maybe we will go through questions like.
So I have a question right now. Okay, let's say this loaded, let's say the contents of register 15 equals so, let's say register 15 equals this value. That means the program is loaded that the first byte of this in the virtual address space, its address is 1234000. So when I'm executing the store multiple, where's the first byte of that address? So you store multiple, it's a 4-byte instruction.
After the execution.
So 90,
Byte.
hex 90 is that address 1234000
On the fourth byte of
of the instruction. So we're done executing store multiple. We did that already. So now we're pointing, we go to Ballard. And where is the first byte of Ballard? Now Ballard assembles into 05C0. So what is the address of 05? Where is that in virtual storage?
Hold on.
It's like 1, 2,
After
3,
the
4,
execution of
0, 0, 0, 4.
Yeah, 1, 2, 3, 4, 0, 0, 0, 4.
In the
You have to be very clear on this, otherwise this is going to be a long 2 hours.
IAR, like in IAR right now, and after Valor it will be in the register code.
Yeah, but I said before Valor executes. It's pointing
In
to,
the register 0.
it's pointing to that 0, 5.
It's like opcode
Yeah.
05.
Valor's being executed right now, so when Valor is being executed,
Yeah.
where's the instruction address register pointing?
Instructor register pointing on the R15 execution.
No, it's pointing to 1, 2, 3, 4. It's pointing to 1, 2, 3, 4, 0, 0, 0,
4.
6.
It was set 4, is there? Is it
You
state?
said before
Is
Valor.
it story multiple?
Oh, before, okay, I make sure. When store multiple, start of the program, it's pointing to 1, 2, 4, 0, 0, 0. When it executes STM, the IAR is pointing to
0.
1, 2, 4, 0, 0, 4.
Yeah.
Next instruction, it's executing Valor, like right now.
Mm-hmm.
When it's executing Valor,
It's pointing to
to
1, 2, 3, 4, 0,
it's
0,
pointing to
0,
this.
Yeah, 0, 0, 0, 6.
Good.
Okay.
Okay.
Without 1 to 3.
Yeah. You guys are not confused. I can be confused, but you cannot be confused. That's good.
It's like if it was 1, 2, 3, 4, 0, 0, 0, 4, now it will be 0, 0, 0, 6.
It will
Right.
be
So right now it's 006.
without
Yes.
1, 2, 3,
When I'm doing
4.
Valor.
У мене після
So-
Valor випише.
So at the end of Valor,
It will be 0, 0, 0, 6.
what is in R12?
One more question before going there. During the execution of Valor, we are pointing to 1, 2, 3, 4, 0, 0, 0, 6.
Yes. That's what the instruction address register points to.
Okay.
After the Valor.
During the execution of
During the
Valor.
execution of Valor.
Okay.
During and after it will be 0, 0, 0, 6. Without
No, wait, stop. We got to finish. Remember we had,
Yes, no.
when to execute an instruction, first we do the fetch.
Yeah, okay.
So we get it from memory, get how many bytes from memory? 2 bytes from memory. So 2 bytes from memory come in. The computer, electronics says, how long is this instruction? What is it? An 05. An 05 is 2 bytes long. So the CPU says increment the IAR 2 bytes. So now the instruction address register contains 1, 2, 4, 5, 6. So what's going to happen? 1, 2, 3, 4, 5, 6 is going to go into,
Register 12.
right. And then because it's an R0, it won't do any more, it'll just go to the next instruction.
Просто register 12, тепер буду зберігати один біточок.
Це шарик, просто він тут півгодини спудає.
So what does Valor do when you have something 0? It just takes the next instruction's address and puts it into register 12. That's all we've done. Good? Now, what we're going to do now is tell the assembler something to match up to what the machine's doing. Now, R12 now is going to be used as a base register.
Instead of R0.
We assign it a base register.
Yes. But if we didn't assign that, it will be.
There won't be one.
It's like it will store in R0 at the top.
It won't do anything. See, the base register means something, not to the machine. It means something to the assembler. We'll see that. Just like to find this picture. Okay. So now we're saying using here, and every time you don't specify that, so what the assembler knows is there's lots of instructions that store is from a register. I'm doing this. Like a store instruction is going to be, some opcode. It's going to have a register, and then it's going to have some place to put whatever's in the register, someplace in memory. And it's going to calculate this memory place with three things. The three things are so it's going to take whatever's in this register and put it someplace in memory. How's it going to determine the memory location? It's going to take the contents of Rx
What is Rx?
of any register, a register.
Okay.
So it's going to take the contents of two registers plus a displacement, and D2 is so the displacement will be any number from 000 through FFF, 3 hex digits. And this happens to be from 0 to
Can we, like, I need to give one thing. One moment, I need to give 1 point.
And during the time, I have a question. If
Yeah.
I have answered it right, like the virtual storage there, it's 000.
Yeah, so this is the virtual storage address.
And there it's 000, and 0001 will be pointing to,
The second byte in this area.
like, here was the question. What will the byte of virtual storage 0001 contain?
Oh, that's right, yeah.
And
And at 0001, you will have a
the part of the instruction.
EC. Wait, I can't.
The path
I'm
is
sorry.
CM, no?
C0.
I'm sorry. Yeah, at 0, 1, 2, 3, 4, 0 is 90. And 1, 2, 3, 4, 1
Easy.
is EC2, 1, 2, 3, 4,
Yeah.
Okay.
Yep.
Good?
Yeah.
So what we're doing is we're placing this guy's, the first byte of this 50 is at 1, 2, 3, 4, so there's no 6.
6, 7, no?
6.
No increment.
0 is it's like.
Oh, wait, I'm sorry, did I put the wrong one? Yeah. See, right when I'm doing the ballot, it's pointing to this instruction. This isn't taking any room, this is just stuff for the assembly. So this ST, this 50, is at offset 6 in my program, and at absolute location in virtual storage, 1, 2, 3, 4, 0, 0, 6. Did I answer your question? Yes?
Yeah.
Okay, good. This asterisk means here. So what this says is the base for the purposes of this program. Every time every time you need to calculate this, if you don't say what this register is, I will use register 12. So that's basically what we're saying. So you don't have to code R12 or R1 or all this. You can just say, if I don't say what the index register is, I'm going to assume I being the assembler. If you don't say what the index register is, then I'm going to use R0. If you don't say which is the base register in the instruction you sent, your code, then I'm going to use register 12. And last thing we got to do is, if I don't tell you the displacement, what is this value? I'm going to do a little calculation. And the calculation I'm going to use is here, which is 6, plus whatever you're talking about.
Yeah, okay, I have a question.
Plus what?
Can we, with ST, if we use like this form of instruction,
Yeah.
to store something in the return code, like in the register for 15?
Later on, what we're going to do is,
yes, like
register 15 is used for 2 things.
for return code and
No, first, the entry point, when you call the guy, and when you come back,
yeah, I understand it. Like
you can have a return code.
yes, can we put something to this register
Yes.
with ST?
Well, here's the thing. When you're coding, there's some registers that if anything happens, they're going to get, something's going to happen to them.
Yeah.
So, normally you just use these registers for this. Register 13s.
Yeah, I
And
understand.
then register 1, register 14 and 15. Usually I leave them alone.
Yeah, but it's possible to do it.
What?
It's possible to store.
It's possible, but it's like not good practice. Do you follow? If you're really running out of registers, you have a special situation, yes. If you don't,
Yeah.
use one of the other registers. So in a way, you do not have many registers for your program. Because you start with 16 registers. 13, 14, 15, and 1 generally are used for something else.
Yes.
Do you see? So look, there's 4 registers right there. Now I just have 12 registers.
I understand.
Okay.
Like the question.
So your question is yes,
Yeah,
but bad practice.
yeah, it's okay.
Okay.
And one more question, when we
Yeah.
do not have the displacement,
I just start again.
when we do not have the displacement like set, what the calculation will be? You said that if we do not put the displacement, the assembler will
Then
make some
the
calculation.
assembler uses, like, instead of this, you write a name.
Mm-hmm.
So it has to convert this name into these.
Okay, it will be done after the whole program.
On the second
runs?
pass.
Okay.
So the assembler's gonna be 2 passes. As we're going through, over here, the guy's gonna say save main, and we're gonna go, I don't know what save main is, but I do know a couple things already. I know, where's our save main? So
Opcode.
50 is,
We need to check ST
I'm- here.
performance.
yeah, so let's do this one here, the store. Store is from right to left. It's gonna take the concept 13 and put it
Mine
someplace.
was DO.
Yeah. So the opcode is D0.
Yes.
D is register 13. How does this assembler know that? Because I told it, hey, 13. But then I didn't tell it anything else. So it doesn't know the index register, it doesn't know that second register, and it doesn't know the displacement. Ah, is that true? But then it says, well, the index register, I'm not saying anything about an index register here. So, good, I'll use 0. So this is that index register. Oh, wait, yeah. You follow?
Okay, what is in this register?
Okay, the address, so this guy, when I'm saying store, he needs an address and an actual location in virtual storage.
Where we take the data?
What?
Where we took the data? Yes?
The data is in register 13 right now,
Mm-hmm.
Yes. Yes.
Okay.
and we want to put it in virtual storage.
Okay.
We want to put it in virtual storage, which is like the second folder. Good?
Yeah.
But the assembler right now, save main means something to you, you're human.
Mm-hmm.
You go, yeah, it's right here.
Okay.
But the assembler doesn't know about words. So it has to convert save main into what? Into 3 things. An index register, the second register, we'll call it base register, and a displacement. So with this, we already told it something. Well, I didn't say anything about index register, it assumes register 0. That's this. And then, what about that second, what we're going to call now a base register? Well, we already told the assembler, hey, every time you see something like this, and I'll tell you what the base register is, use 12.
It's like 12 plus 0 plus 4.
So here's this, wait.
12 plus 0 plus 4.
12.
Like base.
Now, wait, no.
Like base.
No, it's not 4, because it's over here.
Yeah.
So let me tell you where, let's calculate it. Let's say we can, what is the first byte of the first full word? Where in virtual storage will it be placed?
That's a part of ST, no?
It's going to be placed at, oh,
Like 0034.
well, it's going to use this as a base address, which is 6. The difference between 6 and
Okay.
24 is how far?
18.
18, like 0, 0, 18.
Are you human?
Ah, okay.
15. 18.
Okay, so let's do that. One is hex 24, right?
Mhm.
And the other one is
It will be 12.
6.
12 and hexadecimal, no?
What did I say, 6? Okay, 4 minus 6, I have to borrow 16. 20 minus 6
14.
is 14.
It's like 1 and last is F, 1E. I know now how to subtract.
But it's not, it's save main plus 4.
But on the exact time when we
15 plus 4.
Fingers.
plus
F, no G.
Oh,
0,
E,
1,
E
2.
is 14, 18.
okay.
Let's see if I can do that right.
But
Oh,
yes, on the execution
look,
time.
look.
Good job.
So that was one of the questions. Where did 022, I think, I said something like that, like where did 022 come from?
Yes, yes. There was.
You follow?
Yeah.
And the statement 6, we have ST, but object code last 4 bytes to.
C would be register 12,
Okay, but on
and these 3, oh, I'm sorry,
I know. We have the location of save main on the screen, but assembler don't know it on the execution time. How we can
no, it doesn't know any of this, but it knows all of this.
Yes, but the object code while first execution can be full.
Ну так, так і є. Він заповнюється після другого.
То я знаю, що не заповнюється
Ну,
після
так,
другого.
що? Чому там?
Okay, what is in object code before second execution?
When this executes, the computer has this code,
Yes.
right? And when it gets, when the computer, part of the operating system knows that it's going to put this guy at this address. So this is in register 15.
Okay.
Let me make sure I'm answering your question. Then the ballot, oh, here we go. I got a better answer. So, when it's doing that ballot, what is going into register 12?
That address.
So when it's, see, this valor is taking the value of the instruction address register. See, when this executes, it's taking the instruction address register, which is 1, 2, 3, 4, 0, 0, 0, 6. And it puts that into this.
Yes.
So when this instruction gets executed, the save main is actually at address 1, 2, 3, 4, 0, 0, 6 plus, was it 22? 22. And that's why it puts in the second of this. No, it's not, I could tell.
Like, his question was that with what are fields or the fields when
Can I draw it?
Oh, okay, I see what you mean. Yeah, go ahead, yeah. Show me what you mean.
Can you give me?
Yeah, but you get right on this.
Yeah. Okay, we have statement 6. We have
Yeah.
opcode of the instruction.
Store, instruction,
Store register.
13.
And these 2 bytes, we don't know on the first run of the program. Like it's like question marks for
Which
us.
don't we know?
It's like on the first
Yeah,
run. We don't know where is the safe main.
yes you do.
Exactly where.
Save main
Yeah.
is gonna be at 1, 2, 3, 4.
Every time.
Wherever the program loads, this will be hex 24 away from it.
But if we will add our code to this program, like if
No, you're not gonna add any code. This is it. This is all the code. You're not gonna add any more. See this here? This is what the machine has. It's got this and this and this. See all these, this, and right after this guy is this.
okay.
See, so the machine is getting this, looks at this, the CPU, and from 41 it says, well, first of all, how big are you?
Okay.
And
Like
then-
I thought like this program is the standard before every assembly program.
Yes,
Okay, but if we add some code to like we have our screen,
oh, then you reassemble, and you get a new
like new
bunch of
line.
code, you get a new object module.
Okay, we will have the line of our program and then calculate our set main to put it in object code. Yes.
Yeah, this is gonna turn into something like an exe in your Windows. So this is gonna turn into an exe. If you wanna change the code, you gotta go to the assembler, and you'll get a brand new exe,
Okay.
which will have something fit in. And we're gonna do that, because I want you to change this a little bit.
For sure. Okay.
Thank you, I'm sorry, I didn't-
Yeah. Fine.
I usually spend several days explaining this, so
No, now
I'm not feeling bad that you guys are having difficulty, because this is at least 2 days worth of stuff.
It wasn't difficult. It was because misunderstanding. I thought this is like after the second run.
Yeah,
I thought if we gave some additional code to our program, like our assembly program, new, when we created, this is a start of like starting
I
point.
see I see what happened. The assembler needs to go through this, the assembler to produce this code needs to go through all your code twice.
Yeah, that's why.
And when it gets done, it produces that
But
code.
location will be different. Like if we add on our program, not on this.
If you change your program,
Yes, it will be.
you have to reassemble it, and then this will be all different.
So, yeah, that was my question.
Good. For example, let's say a common thing to do here is, let's say everything's fine. And I told you in your notes that register 15, if things go fine, set it to 0. That's sort of the standard. So then the caller looks at register 0 when it gets returned back. Usually if register 0 contains 0, it goes, hey, things are fine, the program worked. If it contains something else, it usually stops or does some error working. Good?
Can there be some runtime errors while execution?
Yeah. So let's say you make a mistake and you, instead of 13, you put in 1. you know, it's gonna go, I'll take whatever's in one, but if it's a bad address, you'll get an address exception.
Yeah.
This is the hardest part. The rest is gonna be easy. So what's in register 12 is the actual location of this byte. And then you say, hey, look, that's what I'm gonna set up at runtime. At runtime, register 12 will get the absolute location of this byte. And for the purposes of our assembly, the assembler is going to use the same point, which is 6. Good? The rest, if you got that, we're all set. Here we're going to take save main. And this will be the address of save main plus, well, I'll do this one. We're going to take the address of save main and put it into register 13.
And in ST, we are taking like register 13 and
Well, first we're going to, yes, so let's do this part. Okay, so let's get it. I'll get back. Okay, so we got the base register is 12. If you don't say the index register, you get register 0. And for the displacement, it's going to calculate the distance between some word a human word, and this here, offset 6. So, so now, what we want to do is set up the standard for the save areas. So the first thing we did is we already stored 14 through 12. Now the other thing we have to do is we have to set up our forward and backward pointers to these save areas. So the other guy's save area, the initiators, our save area. So what happened? We put in for store, register 13 and save main plus 4. We copied this guy right now is pointing to the initiators, the caller save area. We're taking this contents and putting it here. So it's like a backward pointer. What are we doing next? We're taking the address of save main. Save main is where?
Right, so
Which is part of my program.
I put it also.
Yeah, here's. So it's taking this address and putting it where?
to the register 13.
Offset,
Backwards.
wait. Yeah. Oh, that's what I did here, good. Then it loads the address of save main. And puts it into 13. Next. Stuff. So it's going to do a bunch of stuff. And then we're going to call another program. So we want to call increment 1000.
Mhm.
You're looking,
Like, I'm looking for this thing to clear the board
oh,
and to throw the another one.
yeah.
From
Let's
another
see if
one.
there's an eraser. There's not.
Yeah, it's fine.
Good?
I go through all this program.
Okay, this is hard.
No, it's
maybe
not
there's a
hard.
better way to
Like
explain.
it was only the question about object code in LA.
Yeah,
Like it was all what I want to ask.
yeah. So you got two things. You got assemble time
Mhm.
and then run time.
Yeah, it's not even not so hard.
Good.
Like, and the safe main is placed into register 13 to point the
The
stack.
address.
Like, yeah,
Yeah,
to point the stack of a program.
yeah. So the other guy, um, I'll be right back, okay?
Yeah.
Take a break,
Okay.
look at this stuff, and discuss.
Nie, to teraz. Czy ja prawильно записал?
И там другие плоские.
Ну, już na 4.
И чё?
Що?
Ты чё?
Показувати стек програм. У нас стек, ну, типу, то там. Ну, тобі, щоб показати стек програма, знаєш, що таке? Стек, хіп. Куча, стек.
Чё?
Stack of the problem. Просто бісить, як він веде лекцію. Він каже, там половину шаги, то він просто типу, якісь рандомні питання кидає, і мені тобі не. Я взагалі, типу, я йому про одне, він мені про інше. Ні, ну типу, я шарю, що я що по-англійськи, типу, так хірово говорю, що він просто, типу, ну той, написав реалізацію стеку. Типу, або я ідіот, або лежний ідіот.
Добрий день, як ви такі?
Щось таке собі.
Я просто, типу, я його про одне питаю, я не почав про інше.
Можешь мне просто такое?
Те, коли починається program to implement a stack. Still гуглити, це, звісно, дуже важливо. What is stack? Okay.
We're just talking about stack and register 30.
Okay, so here's what's going on with your stack, like in your PC. Is that what you're thinking? Okay, the PC. See, these guys do it this way. So they've got a bunch of save areas that are linked with these forward and backward links. And what the PCs do, they don't link them, they just put them on one on top of another. So then you don't need these forward and backward pointers. You follow what I said? So everybody's got to do the same thing. No matter what the architecture is, when one program calls another, they've got to save this stuff someplace. So here they use this linked list.
And the functions is like in stack. And the variables.
Yeah. And with PCs, like your 86 architecture, they're just doing the same thing, except instead of linking it with this, they just take this part and put it on top of a stack. So you're going to put this like this, and when you want to go back, what do? You just pop these guys off the stack.
And we are using register 13 because just
Everybody decided, like, some guy likes register 13 in 1960.
okay, it's just like default value that should
Right, you can change all these around yourself.
It's like a pointer.
But it was like your question about, like, I'm gonna use register 15th or something. Yeah,
It's like a pointer to the next program.
yeah. Everybody decided, let's do it this way.
Це виконається, наприклад, так, в тебе запитається цоль і починається суду програма, типу з
Yeah, so when you start coding in another machine, you're gonna be doing the same stuff, but you'll have to learn what do they do. You know, what does Motorola do with the 6500? What does Intel do with the 86? That kind of thing. He's just, some guy's got register 3 as his favorite. That's fine, I'm not gonna argue with the guy. So, now, something went wrong, I did something. Let's see. See, this guy had to do this. No. Okay, store 13 and say main plus 4. Load address 13 into save main.
isn't like load save main into register 13.
That's the load address. That was it, yeah. Because 13 is still here. So that was this part. So you gotta put this guy's address here. It's every so often it's wrong.
What is the problem?
You need forward and backwards. So we did an offset 4. We put the caller's save area. And then in this guy's, at this point, we need to put this address. So this guy's got a forward point. Let's continue on with this. Maybe he does it over here. Let's see.
Okay.
Hi. Looks like this guy didn't do that, right?
What?
He didn't,
Like,
he didn't store the forward pointer. You were supposed to.
like forward.
See, this guy's gotta put this address into the other guy's save area at offset 8.
Bro,
And I don't see where he did that. He's got an instructions. You follow?
yeah, it's like it's a
So this is what we do sometimes, we find errors.
Statement 12 is like load address 215. Like it's a return code.
No,
Okay,
this
okay,
is,
I see.
we're doing stuff and then now we're gonna go off to the next guy.
Like we had to do storing 2 times, like in this way and this way.
Exactly,
Or
and
like-
this guy didn't do that. So we found an error, I didn't spot this yesterday, but I was looking at this, but you guys spot this, very good. So later on, we'll fix the program, so we know we gotta do that to fix, and we gotta fix this. The zero out register 15 if things are fine. So, let's call, so now we're here, and what's this guy doing? Do some stuff, and then he's gonna do a load address, save me, I'm not sure why he's doing that. Oh, that's probably a mistake.
Like up.
Let's continue on with this, I see what's going on. Let's disregard this, because he's already done this here. Right?
Maybe for the
All
set.
along, yeah.
For the set.
Yeah, the idea, I see what he's doing. Okay, here's what this guy's doing. He took save main, the address of save main, and he put it into register 13. And then what he's doing, he's playing around with register 13, he's using it.
And loading again.
And then later on, he's saying, okay,
Yeah, reset.
I'm gonna reuse it. So that's what you would do like with 15, what you're talking about. Do you follow?
Yeah.
You'd like save it someplace and then reload it right before you continue. He would have done this if this program was doing a lot of stuff and he needed more registers.
And I have a question. When
Yeah.
we load to the increment 1000 into register 15,
Right,
will
so,
it get into our IIR? Like it will start?
no, so here's increment 1000, and what will go into, what is the actual, what will be the contents at register 15 at runtime? So let's go down, and let's window down just a little
Will
bit.
we have 1, 2, 3, 4, 12, and then
2, 3, 4.
0, 0, 0, 12.
Oh, no, where's ink? You gotta find ink 1000.
It's like lower.
Ah. So ink 1000 is at offset. Wait, let me think. Yeah. Ink 1000 is at 70 minus
60? No.
minus what? Here was 6, wasn't it?
Six.
Yeah, because
Why 6?
remember the using was here, and here for this program is,
But we use it on the 12 location, like 0, 0, 0, 12.
yeah, we're still using 12. This is the same program. This is another routine in the same assembly.
Why we subtract 6?
Because using it, where's our using?
Over there.
Upper. Like one line before it.
Yeah, you guys remember that, right?
Yes.
So the using is here, and here is 6.
Yes.
So when you get the displacement,
It went up again.
the displacement is,
You just have to.
yeah. Oh, what happened?
Slightly close. No.
Okay, oh, we're good now. Okay, 6, see offset 6. The offset of this guy is 6. So we want to know, for displacement, it's got to go from 6 to 70.
Чого чому 6?
Ink, increment 1000, its offset is 70.
Нам треба вернутися
Так,
там,
давай.
де load address.
Yeah.
Чому 6?
So let's see what happens. Well, sure. We'll see, and we'll see what the assembler did. You can tell. First, what is 70 minus 6?
One moment, I just will ask.
You need some clarification, so I'll just.
Зараз я.
Okay.
У нас є от load address, ми load в 15 рік, от цей. Інкремент. Інкремент починається з 70 рядку. Але це окрема програма.
Ні, це продовження.
А нашому заливаємо? Так, нашому заливаємо тоді це в load address return code.
Ми просто в 15 регістрах заливаємо.
15 регістр то return код.
Добре, адресний простір один, а просто різні функції.
Ну, а як ми тоді її викликаємо? Тобто вона коли заливається в 15, вона зразу викликається. Я вам взагалі про то питав, як ми будемо рахувати.
Добре, і.
Ну, воно залилося. Я спитав, типу, воно почне роботу? Я думаю, що не
Ні,
почне.
ви направляєте 6.
Ну чому? Я не зрозумів, до чого тут 6 взагалі, чому ми рахуємо 70 мінус 6.
Цікаве питання. Дякую. Кажіть так, як мені послідовно.
Like like why we are loading this function into the 15 registers because it's
Because
like
we want a branch all the way around here to here.
it will start this function.
Yeah, we're gonna change direction. See, we can't keep executing all the way down here. This is data. These are instructions. So we want, at this point, we want to put the return address, which is this relative location, into register 14. And we want to, okay, what does Valor do? It takes the instruction address register right now. So when this is executing at offset 16, the next instruction is at offset 16, 17, 18. So when we do this other subroutine,
Yes.
we're going to want to go back to
Yeah, it was the question.
here.
Yes. Okay. That was the question.
Розібратися.
Так.
Good. Make sense?
Yeah.
Okay, so 14, again, 15 is going to contain the address of where we're going. 14 is the return.
Yeah, I
Okay, so that's what we're gonna do. 14, 15. So 15, when you're executing this, 15 goes to the instruction address register, goes down here, and starts executing this guy. And this does the same thing. It's gonna. So now, this is all in the same address space. What's going to happen? We're going to have our is it 1,000? Yeah. So you have our program. What is pointing to this point right now?
R15.
Okay. R14. So we start here. This guy has a got a save area. And what does this guy do? Ink 1,000. First thing it does is
save the base register.
R13 now points to here. So it's going to save
Да, якісь такі. Чекайте, що там які
12 це стек, так?
12, так?
Так.
Ні, 12, да.
Є це контекст.
Так. Ми заливаємо 12 поінтів на год.
Yeah, it's small discussion. Just to avoid misunderstanding. Stack address is in 80 or 20 register?
12 or
12 or
15. Stack is like, it's 14 register.
the what?
Stack.
You don't have a stack.
Like,
Like pointers to another program is are always in 13.
No, stack is, no, 12 is the base register.
yes, it's like, типа то не до порівняння.
Ні, ну так, може.
У стек в них працює як? В нас стек це повністю сама програма. Тобто вони йдуть по черзі.
Okay, here's what's going on.
Я сам концентруюся по...
I think this will help.
Could you check
Yeah, I'm gonna do
about
this.
22?
Here, just
Statement 22.
let me. I see what's going on.
Ні, тут читайте. Для тимчасово зберігаються значення. Я це назвав стек, так? Ті, що там треба розділити як 14.
12.
Чи в тому, що він вказує?
А він не вказує нічого, на нього
Ну,
переносить.
бейс регістр.
Ну, без реєстру то 12.
Може, він вказує.
Yeah, I did emphasize this last time.
І пам'яті вроді, так?
There's something called relocatability. Okay, just forget this stuff, just theory. So, we have an address space. And part of this is system code. just gave this as an example. So in the address space, when we get the address space, some of this stuff, we can't use some of these places. We can't use this, we can't use this. The operating system takes this stuff you wrote and puts it someplace. So this code is going to be put into something called, it's going to be like an exe file. So the operating system is going to take all this weird stuff and put it someplace here. Where?
After this.
No, we don't know. We don't know.
Like in memory? Yeah.
Yeah, it's going to put it someplace, but where's the first byte going to be placed? Is it here? Is it here?
Where is 3 bytes?
It just decides on its own. So wherever it places it, so let's say today's a good day and it places it at this location. So when when your program says, hey, I want to go to save main, save main is relative to this place where the operating system put it. So that's why we have base displacement addressing.
Okay.
See, we know when we're assembling, we know the displacement.
Yeah.
We know what register this will be, we don't know what's in it.
Можна пояснити? У нас стеку так якого нема. В нас є, наприклад, цей SA, Storage Area програми. У нас є кінець 12 регістру. Ми беремо перший плюс 12 плюс...
Я це питав, чи 12 зберігає... Я це назвав стек.
Ну, типу, ні, ми не в 12-му зберігаємо. Ми зберігаємо після 12-го в клас Displacement.
Тут у 12-му буде оце 1, 2, 3, 4, 4 нуля чи ні?
Ні, буде в 13-му. This like 1, 2, 3, 4, it will be in address space.
That's the first 4 bytes of the
Yeah, it
address.
will be this address. In which register?
In the instruction address register.
And for data access?
See, what the initiator is going to do is, you're going to say, I want to start my program. Remember the initiator? So here's you go to TSO. TSO sets up an initiator, and TSO decides to put your program someplace. And right away, your program better figure out where it is. Your program has to figure out where it is, not the operating system.
Okay, and where is the address of this variable, for example?
That was the value.
Like in which register?
See, look, right here. Just don't have look. I just want to lift this. Let me see. See that valid 12-0? That's your program saying, wait, where the heck am I? And wherever it is, when you execute that program, it puts that absolute address in register 12. Now your program knows where it is.
Like, and everything will store in register 12.
No.
You have to do it.
The reference point of your program is placed in register 12.
Yeah, this was the question. Maybe I used the wrong word, step, but it was the question. Yes, register 12 used it for this thing.
like where am I?
Я живу в
Воно
іншому.
зберігається ніби в 12-му розвісі, воно просто зберігається десь собі по пам'яті, і потім
12 рік
у нас-
вказівник на це.
він ніби вказівник на початок, плюс якісь дисплейсменти, які ми вже знали.
Так. Я питався, чи я правильно розумію, що в 12-му зберігається ось це, про що ви говорили?
Ви сказали, що зберігається дані.
Ні.
То зберігається.
Вони ніби не
Ні, ну
вкладаються.
відносно нього, ну просто коли єдиний адрес не пройде, я не кажу, я неправильно сформулював. але-
Я тому так і подумав, що в мене вже в голові там...
Ні, це все нормально, це ні, це сам.
Yes.
So, I'm sorry, let's continue from the start to think
Yeah.
how the...
So this allows relocatability. This base displacement, and all modern computers do that, except these little microprocessors. When you put it in, you're going to start off at 0. So you don't have to do this. Do you follow?
Yeah.
Because it's not like you got a virtual address space, you can like, you put it in the first byte, you know, your program's going to start at 0.
Що означає цей індекс? Ніби є base, displacement, а індекс?
Індекс – це нульовий реєстр. Index is like
So the,
R0.
so here's the purpose of index. You got an array.
Окей.
Who did that? So you want to add 1, 2, 3, 4 numbers. So your add, and let's say we're going to add it all into register 3. So let's say array
То не знаю.
Він displacement ми будуть писати теж.
То 0, 0, 0. Привет, Андрей. Yeah.
So I've got 0 in R4 now. Now I'm going to have an add instruction. I'm going to add the contents of these locations into R3.
Ну що, сам з собою десь нуль. Це хочеш зробити.
Це окей.
Потім анекдот розкажу.
No, I'm kind of switching back and forth. Whatever that is. Oh. So what's this instruction gonna do? First I made the contents of R4 0. Okay. And I'm going to use, in this program, I'm going to use R4 as an index register. R3, I'm gonna use that as an accumulator. So, R12 where do I have the displacement? Yeah. So what's going to happen? It's going to add what? The contents of 12, which is the absolute location of the program, plus this byte. So now I'm at this pointing at this displacement, and R4 contains a 0. So I'm pointing at this, so I calculate the address. This, plus this, plus this. I take the 4 bytes here and add it to R3.
Це я казав, що
6C це що?
це що ми додаємо до того.
Запустіть якийсь редактор, я вам щось напишу.
Тут я не
Я ж казав з нульового, правда?
Так.
Ну так з нульового.
Notepad, будь-який.
Редактор.
Yeah, I'll show them equivalent C code.
Yeah.
It should be much.
So then I'm going to increment the address by 4, and now I'm pointing to this, and I'll loop.
Це відкриється.
Все, так.
Ладно, окей, я просто буду не
I'll just write equivalent C code, and
Yeah.
because it's extremely important idea. It works to spend some time.
Except we're going to have an addressing overflow.
Правильно вийшло.
Мені запас буферу у мозку, так?
Та ні, типу я просто потерял нить, як то кажуть.
Ні, та до того я тому не переживав.
Ні, типу я розумію, як це працює.
Ні, я не розумію.
Дивіться.
То воно лінк індексинг робить.
Маєте якісь, ви маєте мінімальне уявлення про січні масиви?
Дуже мінімально.
Значить, я створив масив якихось там. Я тут фігурочки мали бути. Я так тут, знаєте, я це тут так вульгарно пишу. От створив січні масиви якісь, так, є 4 елементи, 4 віта, 4 байти на цій машині. Хочу суму знайти. То я напишу як. Менше. Тут треба, код не гарний, а то не принципово.
Ще погано працює, може.
От я так зложу, я його не дотискаю. Ось, і тут що я напишу?
Знаю.
Ось малювати не було. Можете цей код прочитати чи ні?
Я думаю, вони не зможуть.
Оце, що таке ім'я масиву? Це вказівник на його початок. Я кажу, взяти вказівник на початок того масиву, додати до нього зміщення в масиві, наскільки відступити від початку, тобто номер елемента,
Пам'ять.
і звернути до того. І це додати.
І воно тоді буде давати до цього результату кожного разу зі зміщенням.
Так.
Так, ну це
Ну, буде-
розумію.
Ось, тепер дивіться, у вас R, це є в програмі 0,6C. Тобто він в програмі, відносно початку програми так знаходиться. Це є далі. Оце RES, це є R3. R3 записуємо. Тобто це оця команда отак заземлювалася.
Так.
У вас той код. Тепер оце І присвоїти 0.
Це той А4.
Це R4. Так. Тобто це XOR просто так, це асемблер читати спосіб 0 зберегти. Типу move R0 це довше. Тоді ось тут, власне, оце, що написано, то каже взяти оце, взяти з R12, де почалась програма, то ви розумієте, от R12 буде містити оце, додати оце і додати індекс. Це дасть адресу, тобто це буде права частина цього виразу, що я написав в циклі. і додати його до акумулятора. Тобто оце вираховує адресу. Як вираховує? Ось це з S12, плюс оце відоме компілятору, плюс вміст S4. І тоді те, що знаходиться за тою адресою, додати до R3. Ну, так щось виставити, це розрахунок адреси, а це додавання вмісту пам'яті. Все, можна справді було на питоні писати, але це мені совість не дозволило.
На питання?
Так, ну, в той приклад, що я писав.
А як ви зробите питання?
Ну, не, в тому совість не дозволило, що не зроблю. Розумієте?
Окей, а одне тільки питання. Коли буде індекс інший?
А це збільшення індексу.
So then, every time I go through that, we're going to add 4 to register 4. So now the next address is the contents of 12 plus the displacement, which is the first full word, plus the contents of 4, which is 4. So now I'm pointing to the second full word.
Ні, це розумію. А індекс завжди 0. Чи ні? Ні, я не маю на увазі під час. На початку ми враховуємо повністю адресу.
Ну, очевидно, так.
Ну от я про то і питав, що завжди 0, я ж казав, що завжди.
Ні, ну завжди, не завжди.
Ні, ну я це вулігально, я маю на увазі на
Я
початку.
зрозумів, так. You are asked if index always starts from 0.
No, you can start from wherever you want.
Логічно.
Okay. I'm sorry for intervening, but I think it was necessary.
So I started at 4 just because I could show, like, make it 0. I XOR'd 4 with itself.
It's okay. I'm not, like, I just said before we started all this stuff, that we start from 0 index. Plus 12 to go through all to calculate the display.
Jim, it's just, I think you should know this. In fact, when someone, me or you or Irina, whatever, not sure if he or she understands correctly, then what you do? You propose some idea and ask, would it be correct this? It's kind of,
I see,
you
yeah.
have some mental model of this
How it's
the process.
working, yeah.
And testing it, so those questions was related because we both three were not sure if we have correct
Got
model.
the idea, yes. Yeah.
Чим глубь лісу, тим хуже.
Ну, розібралися?
Так.
Юра?
Та я про то, я так раніше й думав,
Боже,
просто
ти
почала
це?
пояснювати.
Ні,
Ні, так я сказав, що ми з нуля починаємо. Потім почалося пояснювання якоїсь дічі, я взагалі подумав, що я поїхав по скаму.
Розібралися?
Так?
Ні, я про то питаюся. Я розумію, що ви зразу мали правильно. Окей. Let's continue.
Okay, could you move to the statement 22?
Could I do what?
Move to the
Oh,
statement
yeah.
22.
will just...
Yes. We have to move it first. No 22.
And now to 22.
Okay.
Спасибо.
Oh, I see. Okay.
You guys, запис.
So who wants to go up front? Go up front. Let's go through each one.
From each
Yeah,
one.
over by the board. You're teaching me what's going on.
I just wanted to ask you what's going on.
Yes. Go.
Okay, then we are just saying that we are here with this asterisk. What is H?
So, INC 1000 for the assembler, EQU is an instruction to the assembler.
Okay.
So INC 1000 has a value of 70, hex 70. Because that's here.
Окей.
Ну, вона каже, хай цей символ буде рівний поточній адресі. і все.
Типу, щоб знайти початок функції.
Good?
Окей.
So then the next thing, at statement number 23, is going to store 14 through 12, those registers. Where? In,
The colors
This-
save error?
yeah, and this time the caller is
the program that was before.
Yeah, this main guy. So he saved, so we just fill these in.
Okay.
And then what's the next?
Maybe not R0, but R12.
Oh. Yes. 14. Stupid. Very good, thank you. Good. So we store these. Let's see. Yeah. What's next?
Then we make these connections between
Okay, so this guy's save area.
+4.
So we're going to store register 13. Well,
She is asking where will be this statement
I
33?
yeah,
33. Так ти спитала таке, що він пояснив.
so that's it. So now we do this. Agree? Okay, what's next?
Now we are moving register 13 to be pointer to the safe area of this program.
So what they're doing here is their global is going to contain the results of all these increments. So it's just an accumulator. Good. So this is another way to code. So this looks like a literal. It's a literal. It's like defined constant. So this is a combination of two things. Add this defined constant to register 0. Whereas a full word initialized with a human 1000. So you see the full word 1000? You didn't write this. The assembler from here, because you wrote to the end, that was it. And the assembler created this. So every time you say, give me this literal, it'll put this here in what they call a literal pool. So there's the 1000. It's at offset 238, and it's initialized to a inhuman 1000. Hex equals good. It's just a way to help assembler coders code.
What do you want to find? Like
Yeah.
increment or what?
So now we've got this constant, and we're going to add that to register 0. And then it's going to store register 0 the contents of register 0, into this area called global.
And in
See, global is at offset 6C. Where's it?
But it's first run of our program, and we still don't have this address of global. Like
Yes,
we start. Okay, okay, I know.
yeah, global is at this offset 6C in your program. So every time you use the word global, it's going to convert this into three things: base register
Increase and displacement.
and displacement. So what did it use? So the stores of 50 opcode. Make sure I get this right. Store 50 opcode. The base register is C. The displacement of global is 6.6. Why not 6C? Because the reference they're using was at 6, not 0. Okay, so at this, okay, so let's go this, and then we're going to figure out why is this 6.6 instead of 6C? That was one of the questions I had. So first, let's presume that the displacement is 0.66. I'm adding everything to register 0. I'm not using an index register, so it's 0. The base register in this displacement.
how it started to be here.
What it was started.
We haven't written it here, but now we have this global here.
Yeah, you can put a variable and put it in the program.
Асемблер вже знає, що вона буде в кінці.
Що воно
знає, якщо ми знає,
Ні, я не екзекутив. Як мінімум двічі прийдеться.
я це
See,
розумію.
because I branched around all this.
Я так і думав спочатку,
Okay,
що
so
перший
before writing all this stuff, we
Другу
have
See, I write it there.
Я можу помилятися, але принципі, так, але зараз ми ведемо виконання.
I branch. This is a go-to. It never falls into
you'll turn back to
whatever's in 14. But before that, we branch to what's in 15.
Я можу неправильно.
Okay.
Я все-таки...
So it never falls through
Я
this.
думаю, що вона так само.
Okay, so
Тобто я раз
before,
спочатку
but
думав.
before that we have made global.
Yes,
Okay,
I could have put global there, or I could have put it at the bottom.
and it means that we put 0 to the.
No,
We need,
no, load is,
It's registered.
load is this way, stores this way. So load means load register. I'm taking the contents of the 4 bytes starting at global.
And load it to the register 0.
Yes. So now register 0 contains whatever's global.
Okay, and then we add 1000 to the register 0.
Yes.
And then we store
So now global is going to contain 1000.
1000, yeah. And then we store
So now global's happy, it's got the right start. I'm going to continue on, and now we're going to increment 200. We're going to go
what
to
has happened here?
stores this way.
We have stored
This add, this added whatever was in global, and added 1000 to it. In our case, it contains 1000. Then we took this and put it into global. Now global contains 1000.
Всі команди з глобалом екзекютити
А,
з глобалом
окей.
в одному разі.
Під час лікування.
When we do the subroutine, global contains 1000, we're going to add 200. Now global is going to contain
Взяти цей
1200.
дисплей, який він розрахував при компіляції, на другому проході
we are
компіляції.
loading this
Але при
this way.
виконанні там вже просто тупо
А, я-
там прописано
Okay,
66,
so
яка
loading
це
global to the register,
А
we
ви вже
have
прописано.
added 1000 to the register. So now in register is 1000, and then we have loaded this 1000 to the global.
Yeah, so now that storage location, which starts with 0, now contains
Ні, воно
1000.
просто.
Okay.
Він знає на початку вже про нього. Але прийти має добре.
And here,
Now we're going to start calling, now we're setting up to call this other increment.
Ні, я просто сам
So now, that's what we want to do here. We've got 1,000, everyone's happy. Now we're going to call the increment
Він ще
200.
по клубу
Окей.
знає.
Можна.
and
Тут не
now
знаю, але
here,
дякую, не думала, не знати про неї. Я міг не знати.
Так, ні, я не
so
кажу,
this
що провокуєш про
register
машини,
15,
поки що бачиш вже коли
Yeah,
and the next
сам
one
перший
from
поїде.
Right, so now we push 13 into
По тій функції. Глобал він ще не
Safe
знає, де
zone.
знаходиться. Що він його залишає на потім.
Так.
13.
Окей, просто
Right.
будує таблицю.
I
Що він буде з ним робити?
call
Коли його знаходить, просто підставляє.
Так.
I'm making sure 13 contains my,
Тим займався, цим етапом, який зараз треба.
Very
Я про то, я сказав так само, я сказав, що неправильно. Я посилив такий вап.
Ні, ну може не порозуміння правди, ну
see,
почекай.
what happened is that this guy, he's worried that he played around with the change register 13. So he wants 13 now, so when he calls this guy, 13 will indeed call, point to this guy
Я з
here.
Костю, я пішов взагалі,
Would you roll? This is statement 28, 29. This
Та я
statement.
помітив, що він
Yeah.
Бо я туди.
Load address, the address of state zone. So it's gonna take this, this virtual address and put it into 13.
Розділяємося.
Okay.
So now, when this guy calls the next guy, 13 will point to the same address, this guy will save things. Just like this guy, I gotta make sure 13 is pointing to it.
Ні, так по суті, я просто порозумію. Ну, все не знаю. Файн.
This is hard, isn't it?
Проблематика.
Yeah, well, that's. You want to be a big-time computer person? This is good for you. Build strong computer bones.
Багато грошей заплатили тому, хто написав лінкер.
Я вам книжку. I have a book about writing linkers. I'll give them.
Oh, okay.
Я би почитав.
It is in our literacy list. It would be good if you read it.
Until the start of this semester. Okay, I think we can.
There's enough?
For today.
Okay, this was good.
Maybe
Oh, but if you need some wrap up or whatever.
No, I'm happy because I want you did this, now go through all the questions. You should be able to answer, I think, the questions now.
Jeff, do you remember our talk about questions and quiet students?
Yeah.
They are not quiet when they do have questions.
So I was happy to see this actually. I thought everybody was just agreeable.
No,
But if they don't understand me, say something.
Взяли одних самих також студентів, там
no, they just didn't have questions. As you can see, if something is,
Yeah.
we can return 5 times, 10 times until they completely
Yeah.
understood what
This
they're
is
talking about.
normal, actually, you guys are very fast for this.
okay.
Some people just don't get this, and the answer is
That's all.
they shouldn't be in programming. You know,
So now we'll answer all the questions with understanding what is happening, and can we check really fast next time our answer?
oh, of course.
Okay.
Yeah,
Okay.
yes. And then, what I'm doing next time is I think you're gonna get this, and I think you're gonna get the questions. I'm gonna verify that. And then we're gonna change this a little bit. We're gonna do some of these things in a little bit different way. Just to make sure you get the idea.
And why we are not storing like
The forward pointer,
yeah.
because the guy made a mistake.
Okay.
He's not storing the forward pointer. So that's kind of some of the stuff I'll talk about.
Okay.
Okay. Some programs don't do what they're supposed to.
my first computer games was written by such kind of assembly.
Yes.
And you should enter it every time because my device had permanent memory. So I had maybe up to 90 commands, and I have to program that, and then the game process looked like that. For example, moon landing. You have some spaceship, you have some fuel reserve, and you must enter how much fuel you would use and for how much time, and in what direction. It calculates your speed and the remains of your fuel, remnants of your fuel, and continues the process until you are landed or you are dead. Next time you want to play, you should enter this code.
It's like the same situation in Counter Strike. Before every game, you need to enter like at least 20 commands to start, like to set up your environment. And I was very lazy to write a bot which is entering me a command, so I just remember it and enter every time.
You have all skills to know it easily.
But I have one more thing. If you go to this question, there's one more question. What are the first two statements here? They're, let's, like on the top here.
STM
Okay, you
and
got P1 start. And then the next thing I did a store multiple. And then next I did a Valor. And the next thing I did a using. So you need to write this down.
Чешу знаю cheat list на память.
What is FR?
Load register, the contents of 15
Oh, okay.
is going to go into 12.
Okay.
So load is.
And what is before R12? Like using
Using
PI,
P1,
P1.
Here.
see, so P, in other words, instead of here, I'm using here.
Whatever. Actually, what is the problem?
It's easier to read your assembler list in this way.
Like
See, we're off 6.
Yeah, it's not.
So in other words, well, what happens here is R12
It's like the.
gets this address. This, R12 gets this address.
Same.
Remember before we're doing like displacements and it's always like something's off 6? So this way it's,
Much easier.
it's good for humans, machine doesn't care.
Maybe you remember, we were talking about stack frame for x86. It looks to me like a kind of stack frame. I mean, that if you have a stack for x86, you have 0 max address. Yeah. You have args to function. Then you have return address. Then you have local variables. And it looks like this idea is, oh, you need to have top of the stack, and this is stack frame. And stack frame is used the same for the same thing as ARM 12.
Yeah. Instead of a linked list, you have a stack.
So I just so this is the reason of my mistake when I was asking about ARM 12. I used the word stack. Because, I mean, it's
I think that, yeah.
yeah, we have almost all the lecture during our C++ course about that why it done this way. Because other way you should always adjust your displacement. And one interesting thing, every our lecture I see how many are similarities between ARM assembly and IBM assembly. ARM, I mean that's our Cortex M controllers and our smartphones and others. It's assemblies are the same.
У нас є юзінг. Ти коли бачиш юзінг зірочка 12,
Так.
ми веземо саме тут, ми веземо 12 регістр як бейс.
А, окей, ми замість того, щоб піднімати ці всі 6, ми просто будемо їх взяти початок?
Так.
Саме як типу, як вона веземо.
I want to do that tomorrow because what I noticed, if you try to say, hey, I got something else interesting to show you now. So it's another, we have other ways to do the same thing.
Important question. Maybe you can discuss it when we meet next time.
Yeah.
I cannot come in Monday and
Yes, we
Tuesday,
will.
but in Wednesday,
Whatever.
What do you guys want?
3 p.m. and Wednesday.
Wednesday, 3 p.m.? Good.
Wednesday was free.
Just send me a note on,
About
And stack.
notification.
yes, then I show my wife and she tells me go to school.
Okay.
That's hard. Learning taking place?
І я кажу.
This is probably the hardest stuff you'll do.
Ми рідко програмуємо на того, але якщо я переконався, коли моя спроба розказати все те, що цей рік, що я викладав, люди, які цього не знають, ну, майже на інші машини в школі не йдемо, не треба, там не українські. Виявилось інвейно, абсолютно. Поки люди не розуміють до чого, говорити з ними про якусь архітектуру, про якийсь кеш, про якісь суперскалярності, нічого не буде.
Вони просто суті проблеми.
Вони не розуміють, що це проблеми і все. Тому я ще викладаю, що вам ці зусилля однозначно окупиться, а потім легше.
То як вчити тої хірургії без мене на другій.
Так, власне. Ти йому розказуєш про якісь вміння зажимати якісь судини, він не розуміє, що за судини, на що їх зажимати.
Я це зробив, але зачем?
Типа, так.
Дістинки?
In fact, this is necessary to understand all other. I will teach them later. Побачення.
Thanks.